Okay, dear students, today we are going to start chapter number 3, matrices. Okay, so we'll see the definition first. Definition what they are giving, that we'll see definition of matrices. Okay, so what they are telling, a matrix is an order rectangular array of number or a function. Means inside the rectangle we can use either number or function or any other entries you can use, not an issue. Understand? So what I'm writing, just you followed. A matrix matrix is an, what is that, ordered rectangular array. Okay, rectangular array of see here we can use a numbers or function. I'll give an example how we can use a number or a function. Okay, functions we can use. The number or function are called elements or entries. This is the definition. That's it. Here the numbers are functions are called elements or entries. They will say elements are entries, they will say. Understand? Elements are entries of the matrix. Okay, listen to Raja, how we are writing this. Let's see. I'll give you example, then you will understand. Listen. See, a matrix is an ordered rectangular array. Suppose a rectangular array I'm giving. This is a rectangular bracket. Okay. In this, inside the rectangular array, we can use either numbers or functions. Either number or functions. Suppose number means 1, I'm writing this is a number. Even root 2 is a number. Am I right? Or 1 plus I also number, complex number. Am I right? Even 0 is a complex number. Function in the sense x is a one of the function, linear function, or I will use a trigonometric function. Like that, either elements or functions you can use. That inside element or function is called what na? Inside numbers or functions is called generally elements, they will say. What they will say, Raja? Elements are entries of the matrix. See, now first entry means 1 we can say. Okay. So second means, listen carefully children. First element means 1 we can say. Second element na, people may go here or here. Okay, so which is the second element? They may have a doubt. Am I right? Either row wise we have to check or column wise we have to check. May have doubt. So that horizontal whatever you writing, that's called a row. So this is row number 1 and this one is called row number 2. Okay, and down we can say that column. So which is column number 1, and down and next one we can say column number 2. Next one we can say that column number 3. So that now based on row and column we can read the numbers. Okay, so first row second element, listen carefully. First row second column, first row second column na, this is first row second column, this will be. Am I right? First row second column, like that they will be identifying. Okay, so that how they will write in general, this one. Okay, how we can write A11. In base you have to write A11 means first one row, second one column. Always first one row we can mention, second one column. So that root 2 I'm mentioning A12 and 1 plus I am mentioning that 13. Means first row first column, first row second column, and first row third column. Like that we can. Same manner 0 and x and sin x, how we can write? A21 means second row first column. So row first we have to mention, I told you I'm right. So 21 row first, column second. Okay, row, second row, third column. Like this we can mention. Or one more example I will give. This is example number 1. And example number 2, we can write like this also. What is that? Sin x, even cos x, tan x, and 1. Like this also you can write. Okay. And this also matrix da. So here or also one more I will write. Wait. One more I will write. What is that? X square and 2x. Like this also. Now this one is called what? Row 1. This will be row 2. Here column 1, column 2, column 3. Have you understand? So this is the way to represent the matrices. So that a matrix is an ordered rectangular array of numbers or functions. This is the definition of a matrix. Very simple definition. And here the numbers or functions. Number or functions are called numbers na elements we can say, or functions na entries we can say, or generally either entries or elements also you can use, not an issue. Okay. So this is the definition of a matrix. Understand? First you write this. Next we are entering in a what actually order of a matrix. Order of a matrix will go. First you write this. Are we done, Maharaj? Write faster, Raja. So order in the sense nothing. Generally I will tell you order na how many rows and how many columns are there in a matrix, which is called order, they will say. Okay. So while writing order, first always you have to mention row. What, my dear? Row. First, that is what I said. Count. First element must be row. Second element must be column. Understand? That is very important. First element must be row. Second element must be column. Okay, va? Right. Next, order of a matrix. What I said? Order of matrix. So order of matrix what? I already told you how many number of rows and columns are there in a matrix, which is called what is that order? So grammar, what is it? As per textbook, what they are telling, that will write a matrix having m rows. What, my dear? M rows and n columns. N columns is called a matrix. Is called a matrix of order m by n, or simply you can mention that, or simply m by n matrix. Simply you can mention that m by n matrix. Okay, like this also we can write. How you want to read now? Read as m by n. Read as an m by n matrix. M by n matrix you want to read. Listen carefully, children. So generally here you can notice that. So this one is a multiple symbol cross. Okay, multiple symbol cross. But you should not say m into n. Listen, you should not say this m into n. This is the way to read. How you want to read now? M by n matrix. What do you want to say? M by, this is by actually, by n matrix you want to say. So that m by n matrix. That is what I have mentioned here. Read as an m by n matrix. So by you want to use. Okay, by you want to use. While you read, you should use a what is that? By. So how we can? So this one, that is, they said that they have m rows. Rows means how you will mention that m rows. That I will show here. So first A11, A12, A13, it's going that A1n. Why I'm stopped in n means we have mentioned there are n columns. That's it. So in n we have to stop. Like that A21, A22, what is that? 23, 23. It's going and A2 times n. Okay. Same manner it's coming down. Last row, mth row, first column, mth row, second column, mth row, third column. Okay. And mth row, nth column. Okay, this is the meaning. So that this will be row number 1, this will be row number 2, this will be row number m. Understand? Right, like that down. This will be column number 1, and this will be column number 2, and this will be column number 3, and this will be column number n. Okay. So order, how we can mention, sir, this we have seen in the previous page. Order we are talking on, right? Order where we have to mention. See, order we have to mention in this. Listen carefully. Matrix, if you are writing now, this place you have to mention the order. Okay. Order means first row we have to mention by, next column we have to mention. So m by n you have to mention very neatly. Understand? Example I'm giving. What is that example? Here I will give. Okay. So that example, A equal to, I'm taking a matrix. A equal to, I'm taking a matrix. See, the element must be either a number or function we have discussed already. Okay. But numbers alone I'm going to use 2, 4, 6, 1, 3, 5. Here, how many row we have? How many rows we have? Can you tell me? 2 rows. Very good. How many rows, children? 2 rows by how many columns we have? 3 columns. So 2 by 3 matrix. Have you understand how we are writing? This is the way to mention the order. 2 by 3 matrix. So the 2 by 3 is called here order. Understand? Order of the matrix, if they ask 2 by 3 matrix, we have to mention. And B, example B. Suppose I have a 1, 0, 2, 3. So now how many rows? How many columns? 2 rows, 2 columns. How many, my dear? There are 2 rows and 2 columns. Okay. C equal to number 9. How many rows? How many columns? 1 row, 1 column. There is 1 row and 1 column. If even one element also we can make as a matrix. That is what I am showing there. We understand? One element also we can show in a matrix form. 1 by 1, 2 by 2, 2 by 3, whatever the order we can make. 3 by 3, 1 by 4, whatever. Or one more, D example I will give. D example D. D equal to Vanilla, what's your favorite number? Ra? Purvika, are you Vanilla? Vanilla, you tell me. 5, very good. Purvika, you tell me one number. 7. Melvina, you tell me one number. 10. So my favorite number what? Thank you. So this is one matrix I mentioned. This is one matrix. How many rows we have? 4 rows, 1 column. So that 4 by 1 you have to write. Have you understand? Right, that's it. Understand? Some people may compare with the sets. Sir, sets na inside will not give anything, sir. It's called, we are calling empty set. Is that anything we have in a matrix? I'll give only this bracket, sir. I will not write anything inside. Like that, you don't think in a matrix. Matrix, we don't have empty matrix. Empty set we have studied. Okay, empty matrix and all we don't have. But we have a 0 matrix. 0 matrix means what now? All the entries are equal to 0. Whatever the entries inside we have, all the entries are equal to 0. which called a zero matrix, they'll say, but we don't have empty matrix. Understand, children? Don't compare with a sets topic. Understand? Some people, they will, that is what. Okay, have you done this? Write fast, sir. Here there is a mistake. This will be 1 3 1 3. Okay, 1 3. Okay, shall we go next, pa? Right, pa. Pa, next we are entering. What is the topic? Order of matrix we have seen. So in the order of matrix, based on order of matrix, I'll give some few more examples. Wait, Raja. Sometime, see children, sometime example based on order of matrix, I'll give instead of example, I'll give note. In the order of matrix, you want to write a note. What na? See children, see the previous page itself. How many elements we have in a matrix? Element 1, 2, 3, 4, 5, 6 elements we have. So if you multiply this order, number of rows and column when you product, what is the answer? What is the number you getting? That many elements will be there inside, surely. Okay, 2 into 2, then 4 elements will be there inside. 1 into 1, so one element will be there inside. Okay, so that what we are learning through this, number of elements in a matrix, if they ask na, very simple, number of rows and number of columns we have to product. Okay, number of rows, product, this is product, don't think by, it's a product, number of columns, or else product of rows and column can I write? That is, no, down I will write, that is product of number of rows and columns, means number of columns, number of rows and number of columns, that is mn. Here number of rows equal to m, number of columns equal to n. Children, very important note, they will ask in a MCQ question. Even based on this, they will ask 2 mark. How they will ask 2 mark? Based on this, how they will ask 2 mark? They will give yeah, bye said. You tell me any one favorite number, you tell me. Krishna, you tell me. 100, super. So he gave 100. They will give number of elements. If number of elements in a matrix, number of elements in a matrix is 100, then write the possible order of a matrix. Like this they will ask. If number of elements 100 na, what is the order of matrix be possible? Order of matrix. Order means we should write row by column. Like that. Okay. So your answer can be, see, first I will write in ordered pair. Okay, possible ordered pair. Ordered pairs are ordered pairs means I will write in a point 1, 100. 1 and 100 when you product, you will get 100. Next second table 2, 50 when you product, you will get 100. Like that 3 and anything? No. 4 and 25 possible. 5 and 5 and 20, 6, 7 not possible. 8 into what possible, ra? 8 not possible. What? 8 and all will not come. Right? 9, 10 means 10 comma 10. Understand? Like that. Then other way 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 will come. 20 into 5 will come. Means hereafter reverse of this. Whatever we wrote, reverse of this you will be getting. That also you should write 20 comma 5. Then what you will be getting? 25 comma 4. Next what you will be getting? 50 comma 2. Next what you will be getting? 100 comma 1. This is possible ordered pairs I wrote. Okay, ordered pair. If you are writing possible order of the matrix, na, hence possible order of the matrix or see, when you mentioning order of the matrix, how you want to write this? How you want to represent? Yeah, don't say into by. 1 by 100. What do you want to mention, children? 1 by 100, comma. Second one, 2 by 50. Next, 4 by 25. Next, 5 by 20. Next, 10 by 10. Next, Raja? Yeah, 20 by 5. Next, 25 by 4. Next, 50 by 2. Next, 100 by 1. So these all the possible order of the matrix when number of elements is 100. That is what Krishna said. Number of elements 100 he liked. So we gave in this. Understand? Suppose, but don't think they will give this much bigger. They will give 17, 5, 7. Number of elements 17. Then what is the number of elements 17 now? What is the possible order? 17 by 1 and like that. So how many possible? So here in the MCQ, how many possible of the order they will ask? How many you will give count then? Like that. Okay. So how many also they will ask? Then find how many possible orders are there. Also they will ask. Understand? So very important. In a MCQ model, they will be asking this. So based on order, if they ask any creative question, like this only. Understand? Right. Next, what you have to go? Which one, sir? Speak again. 19. 9 possible, Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. 9 possible only. Someone said, I will tell you later. Right, fine. Types of matrices will go to Raja. Types of matrices, very important topic. After learning types of matrices, we can see. Okay. Shall we go? Right. See, when you watch in a video, it may take very slowly. So you make it speed and watch when you see the video. Understand? That is your wish. Can I go next, Pa? Alright. So where I'm going, I said types of matrices, very important, children. So types of matrices, types of matrix. Children, listen. First one, row matrix. What we can say, Raja? Row matrix. Row matrix na what? Okay, row matrix na what we have to say? Types of matrices. Types of matrices. So listen, first what Raja? Row matrix. Row matrix na nothing pa. A matrix which contain only one row or only one column, in the sense that we can say. See, only one column na, which is a column matrix. Only one row na row matrix. Very simple. So the example D, what you will say then here? Column matrix, because we have only one column. Understand? Same manner, we are going to write a row matrix. So that what you What we have to say here? A matrix have square matrix. When we are going types of matrix, I will explain. First, listen. So a matrix having only one row is called what, Raja? A matrix having only one row is called a row matrix. What, my dear? Row matrix. Example what now? See, row means what I said. Horizontally, they will be writing. So matrix A equal to 1, 2, 3, 4, 5 like this. So we have a one row. How many column? We have a 5 column. Column can be many. Column can be many, but row only one will be there. But row only one will be there. Okay. So in general, how they will say, suppose A equal to Aij. Listen here, I in the sense row. First one always row. J means a column. Understand? Sir, outside element in capital, inside is a small letter. Yes. Entries always will be small letters. Matrix always we have to denote it by capital letter. Understand? Don't forget it. Matrix always means this one. Matrix always we have to mention by capital letter. Inside entries will be always small letters. Understand, pa? So I means inside. Inside what we have, that is element. Okay, right. I means row. J means what, ma? Column. Understand? I means row. J means what, ma? Column. Suppose if I'm telling is row matrix. Is row matrix. Now what it should be? General row matrix of order. What we can say that one row, n columns. Column can be anything. This is in general I'm giving. They may ask in a MCQ also. Okay, right. Next we are going in a column matrix. We are going in a column matrix 2. Column matrix na, a matrix having only one column. Simple. Okay. Column matrix. Column matrix. A matrix having only one column is called what, Raja? Column matrix is called a column matrix. Understand? Right. In general, what they will say? In general, A, sorry, there I used A, here I'll use B. B equal to element Bij is column matrix of order m row with one column. Column must be only one. Example I'll give. Matrix B equal to 1, 2, 3, 4. So here we have 4 columns but only one row. So this is called a column matrix. Okay. After this we are moving into square matrix. We are moving into what, ma? Square matrix. For types of matrix you must learn properly. You didn't write? Show me. Write fast. Write faster, Raja. Okay, next square matrix I'm moving. Next what Raja? Square matrix. Third one square matrix. Third one square matrix. Third one square matrix. Square matrix na very simple pa. Square matrix means very simple. Number of rows and columns in a matrix. Number of rows and columns are equal. Okay, equal in the sense we can say that which is a square matrix. Okay, that is the definition I'm gonna give. So a matrix, a matrix, a matrix in which the number of rows are equal to the number of columns. Okay, number of columns is called a square matrix. So that very important note, what you have to see, number of rows and number of columns are equal, means we can say that square matrix. In general, what we can say, okay, in general what we can say, in general what we can say, A equal to Aij, A equal to Aij, here m by m we can say, or n by n also we can say, or Aij n by n. Suppose if you have a m by n, what they will mention, order m they will say, order m they will say, n by n in the sense they will say, order n they will say, that's it. Okay, either this or that we can use. So that here is a square matrix, is a square matrix of order of order of order m or n respectively. First one we can say m order, second one we can say n order. That is what I am giving respectively. Okay, so that here m equal to n, or else here I will mention enough. Okay, that is m equal to n. Simply if you want to say that row equal to column. Okay, example we can give that number 9. Number 9 contain how many row, how many column? One row, one column. So one row, one column means what? Square matrix. Yeah. So B matrix equal to 0, 0, 0, 1. What we can say this? 2 by 2. Okay, instead of 0, if you want to write 6, you write, or 9 also you write, not an issue. But it will be 2 by 2. Square matrix. Row and column must be same. Suppose if you are writing like this, we can say that 3 by 3 matrix. So number of rows and number of columns are equal. We can say that are a square matrix. Very simple. Have you understand? Right. Here very important note I am gonna give. What is the note now? The general way of mentioning a square matrix I will give. General way of mentioning a square matrix. Point number 1. Okay, A matrix equal to, we can give A11. Okay, B matrix equal to, we can give A11, A12, A21, A22. And C matrix, I'm gonna mention that A11, A12, A13, A21, A22, A23, A31, A32, A 3 3, which means what? This is general form of 3 by 3 matrix. This is 1 by 1. What is the order? This is 2 by 2 order, and this will be 3 by 3 order. So through this, what are you going to say, sir? Listen, children. You two want to do in a pencil this. So where we have row and column same, that you note down. Where we have a row and column same. Where we have a row and column same. Listen. Yeah, same element. 1, 1, 2, 2, 3, 3. Where row and columns are same, that is called the diagonal entries. What they will say? Diagonal entries. Okay. So that is I'm going to give here. Okay. So the elements A11, A22, A33, it's going on ANN or AMM, whatever. So this is called the, what is that? Diagonal entries. Or the element A, okay, or diagonal entries we can say. Diagonal entries we can say. This is called the diagonal entries or diagonal elements we can say. Have you understand, children? Okay, right. Now you can give. Okay, now you can give. In a matrix C, what is the diagonal element entries can you give? In a matrix C, the diagonal elements are entries. I told you, elements are entries, you can say. Elements are entries. Okay, in a matrix C, the diagonal elements are, what we can say? 1, comma 4, comma 9. You can see this. This is called diagonal elements. Okay, this is called diagonal elements. Have you understand, children, what is diagonal element? Sir, just see carefully. Based on this note only, we have a next definition. Means next type of matrix we have. Next, then you comes to know what is next type of matrix? Diagonal matrix. Very good. Next type of matrix, what are Raja? Diagonal matrix. Before going diagonal matrix, you must know what is diagonal word. That is what I gave here explanation. So but very important thing, diagonal matrix, square matrix must be square matrix. Diagonal matrix also square matrix. Okay, diagonal matrix also must be what here? Square matrix. Next one matrix is there, scalar matrix. Next one is there, identity matrix. So identity matrix, scalar matrix, diagonal matrix, everything must be square matrix. Then only this is possible. Otherwise, which is not. Have you understand, children? Is it okay? Is it okay? Have you copied everything? Right. Why side over, Appa? Right. Next, diagonal matrix we are moving. Diagonal matrix we are moving. What I said? Diagonal matrix. Definition number 4. So I told you that diagonal matrix must be what I said, square matrix. Diagonal matrix must be what I said, square matrix. So while you starting the definition, you can start a square matrix. You can start with a square matrix having what is that? Except diagonal matrix, all other elements are equal to 0. Listen, except diagonal elements, other things will be what, Paraja? 0 you will be getting. That is called the diagonal matrix. Very simple. That is I'm going to give here. Okay. Just write what I'm giving. A square matrix. A square matrix. So B is equal to Bij or A equal to Aij. You can give. Here row and column equal. Already we have seen. Square matrix na row and column must be equal. Is said to be diagonal, matrix if if all its non-diagonal, all its non-diagonal elements, all its non-diagonal elements are a 0. Okay, 0. In general, how I'm gonna give this, listen. In general, B matrix equal to Bij of order m by m, which is equal to, listen, so what we have to give, 0 if, what we have to say, yeah, 0 if I and j are not equal. If I and j are not equal, elements are equal to 0. Okay, va? That's it. Example I will give. Example I will give. So A matrix equal to, so when you write one by one matrix, not an issue, because same will be not equal 0, right? So number 9 will be diagonal entries, we can say, and B matrix equal to 2 0 0 5. So this will be 2 by 2 matrix. Understand? And matrix C equal to -1 0 0 0 root 2 0 0 0. Anything else? What we can give? 6. Okay. So this is 3 by 3 matrix. So what we have learnt here, except diagonal elements, other entries are 0. That is they are telling. Okay, all non-diagonal elements are 0. Non-diagonal elements. Then what is the meaning of that? All non-diagonal elements means when we have row and column not equal, it will be 0. Understand? No, it will be open. No need to close here. Understand? Right. Ma, when you mention that, this is the way to represent. Okay, one they'll write, one they'll write. If you have a second, this is no need to close. Let it be. Okay, right. Children, so this is the diagonal matrix. So diagonal matrix na, diagonal elements will not equal to 0. Other than all will be equal to 0. Have you understand, pa? Next, what? Square matrix. But square matrix, other things and all, we'll see in the next class, Raja. Okay, time up. Means in a 7th period. Boys, what do you say? Oh, boy. Okay, thank you, children. Boy. Children, listen. In the previous video, types of matrix, order of matrix, matrix definitions we have seen. In the types of matrix, still diagonal matrix we have seen. Column, row, square, and diagonal we have seen. Okay. The next continuation, scalar matrix we are going to start. Scalar matrix na definition itself, what in the sense? See, in a diagonal matrix, all diagonal entries are same. All diagonal entries are same na. We can say that which is a scalar matrix. Before that, diagonal matrix what are, Raja? Apart from diagonal elements, other elements and all what are, Raja? 0. So that suppose diagonal elements you have a 1 0 0 0 root 2 0 0 0 3 if we have. So this things is called a diagonal matrix. Okay. So this never be same in a diagonal matrix. Suppose if it is the same, instead of what is that, root 2 3 is there, instead of 1 and 3 na, this one is called a scalar matrix. This one is called what, Raja? Scalar matrix. Sir, not 3, sir, not 3, 1 I am giving, sir. 1 if you are giving na, which is called a unit matrix, which is called what, ma? Unit. Okay, answer. The diagonal elements are equal to 1 in the sense, which is called a unit matrix. Other than 1, any same number is coming in a scalar, or different elements are coming in a diagonal entries na, which is called a diagonal. Understand? That is I'm going to write here. So a diagonal matrix, you can start to write diagonal matrix is said to be scalar in the sense is said to be scalar is said to be scalar matrix if its diagonal elements are equal. Its diagonal elements are equal or same, whatever you can mention. Okay, diagonal elements are equal. Okay, in other word, what we can say, that is in general. Okay, in general, what we can say that A equal to Aij. This also should be square matrix. So m by m. Here, what you will be getting? 0 you will be getting, or a constant you will be getting. When you will be getting constant? If I equal to j, I and j is equal, you will be getting constant. If I and j is not equal, you will be getting a 0. That is example I am giving. Example, suppose a equal to, if you have a constant, constant means same number. Okay, k belongs to any constant. Okay, where k is some constant. K is some constant. Constant can be anything. If I'm giving a number 9, 0, 0, 0, 9, 0, 0, 0, 9. So diagonal entries should be same. Then it is called a scalar. One more example. Suppose if I'm giving a 3, 0, 0, 3. So this we can call that scalar matrix. We understand? R C equal to only one element, that is what, number 9. So this 9 we can call a scalar, even diagonal, even square. Okay, everything it will be coming. This C equal to 9 we can call scalar matrix, diagonal matrix, square matrix, whatever. The order is what here? 1 by 1. This order will be 2 by 2. The order will be 3 by 3. The thing is what? The diagonal matrix, in a diagonal matrix, all the diagonal elements are equal. In the sense, we can call that scalar matrix. That's it. Next, identity matrix where I'm going. Next, identity matrix I'm going. Shall we go next, Raja? Yes, Abba. Right. Right fast. Question number, sorry, formula definition number 6, identity matrix. Identity matrix. Okay, identity matrix. This is also what? In a diagonal matrix only we have to start. In a diagonal matrix, all the diagonal elements are equal to 1. Then we can say that which is a identity matrix. Okay, right. So that you can start. So in a diagonal matrix, all diagonal elements are entries. Okay, in a diagonal matrix, all diagonal elements are equal to what, Raja? 1 is equal to 1 is equal to 1. Then it's called identity matrix. Identity matrix. Okay. In general, matrix A equal to what we can say? Aij. Square matrix in the sense m by m will be coming. So it will be 0, and here 1. When it will be 1? When it will be 1? I and j are equal, it will be 1. Or I and j which is not equal, it will be 0. Okay. So if it is a 1, then only we can call that identity matrix. Understand? That's it. Examples I'm giving. Examples: A equal to, we can give that, not A, we can mention that I3. I3, identity matrix 3. I3 if you mention, we can write that its meaning I3 means order is 3 by 3. Order is what it means? 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. The meaning of I3, 3 by 3 matrix is the meaning. And we can mention that I2 also. I2 in the sense order 2 by 2. 1, 0, 0, 1. This is called 2 by 2. Even we can mention I1. I1 in the sense element inside will be 1. This will be 1 by 1. Understand? So identity matrix which is denoted by I we can mention. Okay, pa? Right. Next, right fast ma. Next, seventh one, zero matrix. Zero matrix already I told you. Have you remember in the last video I said? What I said? Zero matrix means what? Very good. All the elements will be equal to 0. Then it's called zero matrix. Very good. Right fast. Once introduction, if you are clear, sums and all you can do very easily. That is what introduction I am taking slowly. Sums you can go little fast, not an issue. Introduction, if you are clear, you can go like anything in sums and all. Really, it will be easy. Metrics, people, they are studying in 9th, 10th itself, these things. Right. So, can I start the zero matrix, pa? Can I start the zero matrix? Or else I will give in the this side itself. Okay, seventh one, zero matrix. Zero matrix. So zero matrix need not to be square matrix. It can be anything. Okay. We have seen that square, diagonal, scalar, unit. These things order must be same. Am I right? Row and column must be same. But zero matrix need not to be square. It can be any form. Right. So a matrix said to be zero matrix or null matrix or void matrix. All elements are equal to 0. Then we can say, okay, a matrix is said to be zero matrix if all elements, all its elements are entries, you can write. All elements are equal to 0 or equal to 0 or 0. Okay, all elements are 0. That's it. Very important note what I said. Zero matrix need not to be square matrix. Example, I'll give example first, then I'll give the note. Example what? Zero matrix, we can mention that O you can mention. Okay. So zero matrix, we can mention that O equal to 0, O equal to 0, 0, 0, 0, 0, 0. It can be any order I said. O equal to or square also you can 0, 0, square. This will be 1 by 1. This will be 2 by 3. This will be 2 by 2. Okay. So O means what? Zero matrix. Understand? Note that zero matrix need not to be square matrix. You can write somewhere else. Or here I will write. You just write down of that example. Okay. What is that? Zero matrix. Or it can be square also. No need to mention that. No need to mention zero matrix need not to be a square matrix. If it is a square matrix also not an issue. It's not necessary that it should be square. It can be any order. Understand? So leave it. That's it. So types of matrix we have seen, children. Next one more what? Equality of matrix. Equality of a matrix. So equality of matrix in the sense two matrices are equal, in the sense we can say equality of matrix. Equality of matrix in the sense inside elements of the matrix also will be same. Two matrices are equal na. Inside entries what all we have, that will be same. That is called equality of matrix, they will say, or equal matrix they will say. Understand? Right. Next one we are moving. After telling that, we can go directly exercise. Understand? Only one. Sir, tell me. Yeah. Equality of matrix, only one we have still. Okay. Can I? Right. So next, what is that? Equality of matrix. Equality of matrices. So two matrices are equal now. What you will say? That is the definition. Right. Two matrices are said to be equal. So two matrices A equal to Aij, listen, and B equal to Bij. Two matrices A and B are said to be equal. Said to be equal now if what all conditions should be satisfied. Children, listen. Two matrices are said to be equal. Equal only, equality I am telling. Two matrices are said to be equal now. What all conditions should be satisfied? First condition, order must be same. Order of A matrix, order of B matrix must be same. And corresponding elements are same. Means A11 element here, in the next matrix A11 will be same, like that. Understand? That is I am going to write here. If point number 1 star you just put, if they are of the same order. Okay, both should have same order and corresponding element should be same. Okay, that is what each element of elements of A is equal to the corresponding element of B. Corresponding element of B, that is Aij equal to Bij. Means inside element what we have in the matrix, that Aij and Bij will be equal. Okay, Aij, Bij will be equal for all I equal to j. Understand? For all I and j. Sorry. For all I and j. What all I, what all j you taking, it will be equal. Example I will give, then you will understand. Okay. Right. Example number 1. A equal to, if I am giving any number we can take. Suppose if I am giving 1, 2, 3, 4 na, even B matrix also should have 1, 2, 3, 4. This is one example. And example number 2, C equal to 1, 2, 3, 4, 2, 4, 6, 8 in the sense. Even D matrix also should have same. Okay, 1, 2, 3, 4, 2, 4, 6, 8. So this is called the equality of matrix. Order must be same. Here 2 by 2 matrix I used. Second one I used 2 by 4 I used. 2 by 4. 2 rows, 4 columns. Okay. That's it. Very important thing. Shall we go exercise, Raja? Okay. Children, exercise we will see in a separate video better. Okay, we'll complete this video. Thank you, children.